This video is about water oceans of chapter 13 of class 11th NCERT book. We will discuss hydrological cycle, relief of ocean floor, major and minor reliefs, temperature of ocean waters, horizontal and vertical distribution of temperature, and salinity of ocean waters. About hydrological cycle, water is a cyclic resource and it can be used and reused. Water also undergoes a cycle from the ocean to land and land to ocean. The circulation of water within the Earth's hydrosphere is in different forms, liquid, gases, and solid form, is known as hydrological cycles. Hydrological cycle can also be defined as the continuous exchange of water between oceans, atmosphere, land surface, subsurface, and organisms. 97.25% of water is found in oceans, so is salty and is of no use. 59% and remaining is the fresh water. 59% of water that falls on the land returns to atmosphere through evaporation from ocean as well as other places. Renewable water on earth is constant, whereas the demand is increasing, leading to water crisis. About the relief of ocean floor, oceans are confined to great depressions of earth's outer layer. Oceans merge naturally into one another and are difficult to demarcate, but are divided into 5 oceans. Now a major portion of ocean floor is found 3 to 5 km below sea level. Ocean floors are rugged with world's largest mountain ranges, deepest trenches, and plains formed by factors of tectonic, volcanic, and depositional processes. We will now discuss the divisions of ocean floors. The continental shelf is the extended margin of each continent occupied by relatively shallow seas and gulfs. So it belongs to continent, though it is a division of ocean floor. It is almost flat with an average gradient of 1 degree or even less. The shelf typically ends at a very steep slope called shelf break. The width of the continent shelves vary from one ocean to another. It is on an average 80 km in width. It's missing in places like coast of Chile and west coast of Sumatra, whereas it is 1500 km in Siberian shelf in Arctic Ocean. Its depth also varies. It varies from 30 meter to 600 meter, and the continental shelves are covered with sediments which are brought by rivers, glaciers, wind from the land and distributed by waves and currents. So these sedimentary deposits are the sources of fossil fuels. So the important point about continental shelf is its gradient, its slope, its width, its thickness, and the presence of fossil fuels in it. About continental slope, the continental slope connects the continental shelf and the ocean basins. It begins where the bottom of the continental shelf sharply drops off into a steep slope. The gradient is 2 to 5 degree, depth is 200 to 3000 meter, and slope boundary indicates the end of the continents. Generally, canyons and trenches are observed in this region. About deep sea plains are gently sloping areas. These are the flattest and smoothest regions of the world, and their depth varies from 3000 to 6000. These are covered with fine-grained sediments like clay and slate. About oceanic deep or trenches, these are the deepest parts of the ocean. Trenches are relatively steep-sided, narrow basins, and 3 to 5 kilometers deeper than the surrounding ocean floor. So they are 3 to 5 kilometers deeper than the surrounding ocean floor. These occurs at the bases of the continental slopes and along island arcs and are associated with active volcanoes and strong earthquakes. They are significant in the study of the plate movements. There are 57 deeps explored so far, and maximum is in Pacific Ocean, followed by Atlantic and then in Indian Ocean. Besides the major relief features, there are minor relief features also in the ocean floors. Mid-oceanic ridges is composed of two chains of mountains separated by large depression. The mountain ranges can have peak as high as 2005 meter and even reach above the ocean surface. Iceland, a part of the mid-Atlantic ridge, is an example of that. Seamount is a mountain with pointed summits, whereas mid-oceanic ridges are ranges of mountains. Seamount is a mountain with pointed summit. It is rising from the sea floor but does not reach the surface of the ocean. Its height is 3000 to 4000 meter tall, and they are volcanic in origin. The Emperor Seamount, an extension of the Hawaiian Island, is in Pacific Ocean, is a good example. Submarine canyons are the deep valleys found cutting across the continental shelves and slopes. The Hudson Canyon is the best known submarine canyon in the world. Geodes are the flat top seamount. See, earlier we had discussed about the seamount. They are the mountain with pointed summits, but geodes are the flat top seamount, and this shows the evidence of gradual subsidence through stages to become a flat top submerged mountains. There are approximately 10,000 seamounts. Atolls are low islands found in the tropical oceans consisting of coral reefs surrounding a central depression. It may be part of the sea or sometimes form closing a body of fresh brackish or highly saline water. If you try to find out by yourself, that will help you to remember the things for a long time. We will discuss the vertical and spatial variations of temperature. The important point is that heating and cooling of the oceanic water is lower than land. The main factors that affect the temperature distributions are: number one, latitude; the second is unequal distribution of land and water; third is prevailing wind; and fourth is the ocean currents. Latitude, the insolation received by Earth depends on the latitude. The temperature of surface water, therefore, decreases from the equator towards the pole because the amount of insolation decreases poleward. Unequal distribution of land and water. The ocean in the northern hemisphere receives more heat due to their contact with the large extent of land than in the southern hemisphere. Prevailing winds, the wind blowing from the land towards the ocean, drive warm surface water away from the coast, and that results in upwelling of cold water from below. So there is a movement of cold water from below to the top, and it results in longitudinal variations of the temperature. Whereas onshore wind piles up warm water near the coast and thus raises the temperature. So this is the vice versa situation. Next is ocean currents. Warm ocean currents raises the temperature in the cold areas, while the cold current decreases the temperature in the warm areas. So Gulf streams raises the temperature near the eastern coast of Northern America and the west coast of the Europe, while the Labrador current lowers the temperature near the northeast coast of North America. This is an example of how ocean currents affects the temperature. Temperature depth profiles shows how the temperature decreases with the increase in the depth of ocean. The temperature structure of oceans over middle and low latitude can be described as three-layer system from surface to the bottom. The first layer represents the top layer of warm oceanic water. It's 500 meter thick and the average temperature is between 20 degrees Celsius to 25 degrees Celsius. Within the tropical region, it exists throughout the year, but in mid latitudes, it develops only in the summer. The second layer, called the thermocline, characterized by rapid decrease in the temperature with increasing depth. The thermocline is 500 to 1000 meter thick. The third layer is very cold and extends up to the deep ocean floor. In Antarctic and Arctic region, the surface water temperatures are close to 0 degrees Celsius, so the temperature change with the depth is very slightly. The average temperature of surface water of ocean is about 27 degrees Celsius and it gradually decreases from the equator towards the pole. The ocean in the northern hemisphere records relatively high temperature than in the southern hemisphere. The highest temperature is not recorded at the equator but slightly towards north of it. The maximum temperature of the ocean is always at the surface because they directly receives the heat from the sun, and the heat is transmitted to the lower sections of the ocean through the process of convection. It results in the decrease of temperature with increasing depth, but the rate of decrease is not uniform throughout the temperature. Falls with very rapidly up to the depth of 200 meter and thereafter the rate of decrease of temperature is slow down. That's very obvious because the heat. We will now discuss the salinity of ocean water. Salinity is expressed in terms of ppt, which is grams of salt in 1000 gram of seawater. The factors that affect ocean salinity are evaporation and precipitation at surface layer of ocean, the flow of fresh water from rivers, and freezing and thawing of ice in the polar regions. Wind and ocean currents also transfer the seawater and affects its salinity. The salinity of normal open ocean ranges between 33 to 37 ppt. In Pacific Ocean, it is 35 to 31 ppt, and the average salinity of Atlantic Ocean is 36 ppt. Salinity also changes with depth. Change depends on the location of the sea. Salinity at the surface increased by the loss of water or ice or evaporation, or decreased by the input of fresh water. Salinity at a depth is very much fixed. The lower salinity water rests above the higher salinity dense water, and salinity generally increases with depth, and there is a distinct zone called halocline where salinity increases sharply. This is same like thermocline in case of the temperature. With this, the chapter has come to an end. If you like the video, please press the like button.